When to use protective glazing in the wind and impact zones. Welcome to Building Knowledge 101. In this video, we looked at the importance of understanding how and when to use protective glazing in wind and impact zones, considering the vulnerability of regions from the northeast of the United States through Florida and into Texas. There are multiple versions of International Building Code, IBC, on the market. You will see here 2009, 2012, 2015, or 2021. IBC has been adopted in many states with high velocity wind zones, and IBC is required across the nation, but again, different versions are adopted by different states. So make sure, depending on where you're located, make sure you know which version has been adopted for that area. IBC uses ASCE 7 to determine ultimate and allowable stress load. For occupant category 2 buildings, the ultimate wind load is the one that could occur within a 500-year time period, greater than the 50-year cycle, which is considered for the earlier versions of ASCE 7. It still uses most of the same variables, but yields a higher design load due to higher wind speeds. The code does allow some components of a building envelope to convert from the ultimate wind load to the allowable stress loads by multiplying the ultimate wind load by 0.6. ASCE 7 allows for factoring the ultimate wind load by allowable stress design wind load by multiplying by 0.6. Here's an example of this. The ultimate wind load is calculated at 50 psf. This can be multiplied by 0.6 to determine the equivalent allowable design load of 30 psf. So again, check the specification because there are two different wind loads that are calculated in accordance with ASCE 7, the ultimate wind load and the allowable wind load. So based on the project and the owner and the occupant or where the building is located, one of those wind loads is going to be placed. So make sure that you have the correct one. If the ultimate wind load has been specified for a fairly typical inland commercial building, do question if that's what they need, or can it be factored by 0.6 to the allowable wind load. In most cases, most commercial buildings are using allowable stress design, but just make certain of that on your project. So most of the maps that we've focused on in Florida, IBC is not located to just Florida, though. It moves up along the East Coast and the Gulf states. This map shows IBC wind speeds addressing our coastal areas from northeast all the way down through Texas. Also note that this map says Category 2. This is the most type of category for commercial construction. There are a total of 3 category maps used in IBC 2018, as I'm referencing here. There's a map for Category 1, there's a map for Category 2, and then another that combines Category 3 and 4 together. So again, make sure that when you're looking at your project, you know which category your project falls into, and you're using the appropriate wind speed map based on the category of your building. IBC section 1600 lists the variables that go into calculating wind load. This is important to note. In section 1603.1.4, IBC clearly points out that it is the responsibility of the design profession to include the wind load in terms of PSF, or pounds per square foot, in the components and cladding chart. So again, note this is very, very important that it is the design professional's responsibility for including in a components and cladding chart the different zones of the project and what the appropriate wind load is in terms of pounds per square foot for each zone. We're working on a project and determined that it is going to require impact rated systems. Now we use ASCE 7 to determine the project specific wind load. So is it going to be load resistant wind load, which is the ultimate wind load, or is it going to be allowable wind load? Wind loads are project specific. Design loads are determined by ASCE 7. There are 3 variables that go into determining the wind load at each project. The wind speed in terms of miles per hour from the appropriate IBC map. The project exposure is called out. Then the project importance factor must be indicated. This information is typically provided in the general notes page of the structural drawings. ASCE 7 is used where IBC 2009 and older governs. It is important to remember that IEC 7 and newer references LRFD, or load resistance factor design, to determine wind pressures, while the older version of ASCE 7 or older only had allowable stress design to determine wind load. So after ASCE 7 and newer, you have both the ultimate wind load, and the allowable. So you need to make sure you're using the correct chart. Here's an example of a components and cladding chart showing the positive and negative pressures calculated for each zone. IBC requires this type chart be included typically in the general notes section of the structural drawing. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.